Hey guys, welcome back to C# Tower Defense. Today we will talk about the resources, and here let me kind of break confusion here. I'm not talking about the Godot resources because that's a thing. So that's kind of the complex thing when you're dealing with Godot, because you have the resources from Godot and the resources in the kind of game design concept. So here we're going to talk about resources in a game design concept, which is, think of it as a currency that we're going to be using to create towers and sustain enemies reaching the end path. So if you've played Gemcraft and remember the game, then good job, because that's what we're doing. One resource to create towers and at the same time tank enemies. This resource is going to be mana. Instead of, having lives and gold and stuff here, we just have to manage that one resource, mana. So there are plenty of ways to do that. Except that here we have C#, and because we have C#, we're going to use the C# tools to make this feature work for us. Okay, so basically, when you're using Godot and GDScript, you have to rely on a lot of Godot features for that, including resources, signals, etc., etc. But here, C# is a much more robust and capable language alone, so we don't necessarily need those Godot things behind it. So for this episode, we're going to create a new folder, which is going to be the scripts folder. And I don't know, what color can it could be pink. So in this script folder, we're going to create a new script, which is going to be mana.cs. And here we have the public partial class mana extending node. I'm going to remove the node extension because I don't want this to be a node actually. Eventually, I may want this to be a resource in the future, but right now it's not necessary. So the point of this class here is going to be static. The thing is that some classes or objects in your game don't necessarily need to be instantiated and duplicated, and when that is the case, you can work with static. And this is what we're going to be doing here, because the thing is, yeah, you only need to manage mana only once, right? Like, we don't want the game to handle different games at the same time in parallel. So let's create our first property here, which is going to be the amount of mana the player has. It's going to be public static integer. Let's make it an integer. And we're gonna name it mana with a lowercase for the value, right? Uppercase the class, lowercase property. And that's pretty much it, right? We just need to keep track of the mana in and of itself. So at the moment, any kind of entity can actually come, open this class, and change the mana value. Eventually, it's something that we want to disable in the future, but at the moment, let's leave it open like this. In order to make future work simpler, we can create methods which are going to take care of simple transactions like adding mana, removing mana, or checking how much mana we have and checking if we have this amount of mana. This kind of useful methods. So let's actually create those methods by using public static, and at the moment I'm going to make it void, but eventually I will update it in the future. Like create mana. I have create mana. Second one is going to be consume mana. Actually, since we have, this is part of the mana class, we actually can say create consume without specifying mana. Let's see, public static void can afford. That's one I usually like to have. Let's look at those methods individually. So create here, we actually want to create a specific quantity of mana. So we need an argument quantity. And we're just gonna add it. Okay, so mana plus equal a quantity. A check we can do is checking that the argument we have is not negative, because if it is negative, it's going to reduce mana, and it's not something we want. So just in case if for some reason the calculation makes the quantity being inferior to 0. We're gonna return, and eventually we're gonna throw an error just to show the dev that something's wrong. So here, trying to add negative mana, create negative. Okay, so consuming is a little bit more complex. So I'm just gonna keep it simple at the moment, and eventually later in the future, I will change it, upgrade it. So here we're gonna have the int quantity as well, and we're gonna do the same thing. Okay, mana minus equal a quantity. And we're gonna check two things as well. If the a quantity inferior to 0, we're gonna say that here GD print error, trying to assume a negative mana value, trying to consume. And we do return. Now, something else could happen, which is having a quantity superior to mana. Okay, so in that case, it means that you don't have enough. So gd.print error, trying to consume more mana than stored. And if we actually have a positive quantity, do have enough mana, then we can remove safely from the game. Let's actually make a public static can fold. Okay, so here's actually simple. We're just returning a quantity, so we need to create a quantity being inferior to mana, inferior or equal. Let's add this integer a quantity, and it's gonna return a boolean. So this method would just tell us, do you have enough mana for this purchase? Yes or no? And eventually we can use that in this method here. Okay, so it's not really an error. Let's actually remove the print error here and update the condition to can afford a quantity. So if we can't afford by saying a not can afford, we're gonna return, and we're not gonna print an error because it's actually supposed to happen something. Now, with the consume method that I've created here, it returns void, and honestly, it's, in my opinion, quite important to make it returning something, like a boolean, usually, true, false. Just because we want to know if the attempt to spend the currency has worked or not. This can be important when you try to, let's say, purchase a tower, for example. Let's say that you try to purchase a tower and the transaction is refused for some reason, then you don't want to create this said tower. Okay, so that's why returning a value here can be interesting. So we're gonna return a boolean, and when we have errors, we're gonna return false. And when everything's fine, we're gonna return true. So because this is a C# class and not a node, we don't have to specifically add it to the game by adding this node to the scene tree. Okay, this is part of the program, and this can be accessed anytime. Now, let's say that for some reasons we want to create a label, or let's say a header at the top of the screen that displays informations like the mana, for example. Let's create a new scene, which is going to be user interface. So here that's going to be user interface. And before we do anything, I just want to go in the control of this, the mouse input of this control, and ignore the mouse filter, right? Because I don't want this object to be blocking the mouse when we click in it. So right here, this user interface, as you can see, it is positioned right to this bottom right corner of the origin of the axis. And it's actually going to be a problem with the world 2D we have here, because you know the camera is offset to the center of the axis. So if we do add this control object interface to the world, it's going to be basically appearing right here. Well, actually, in this entire blue rectangle. But since I want a header, the header will appear right in the middle of the camera here. So in order to kind of fix this, what we can do is, instead of just having a control node, we're going to create a new canvas layer, which is going to create a display layer on the screen so that they are both independent, the 2D world with the camera and the user interface on the front. Point is that when the camera is going to be moving in the 2D world, it's not going to impact which part of the screen we're displaying for the user interface, which is in its own layer. So here I'm just going to do something a little tricky. I'm going to create a canvas layer, and I'm going to right click and make it the scene root, and I will name it user interface. This one's going to be control. Okay, so now the user interface is in a separate canvas layer, and I will actually save it in a scenes folder, which is going to be gray because canvas layer is gray. And I actually saved, which I do. Now let's actually create a header. So I'm going to create a panel, which is going to be stretching at the top of the screen. And I don't know, something like 80 pixel wide. That could be okay. Just I'm going to create a label in there. Is going to be taking the entire space with center text. Okay, so here we have mana. Actually, we have mana equal value. Let's keep it this simple so far. Just add it to the world and see if it works. Here, user interface, adding. Okay, so as you can see, it is offsetted right now. But if we do run the scene, we'll see that it is actually showing at the top. Right, so here the mana value is actually showing at the top, which is exactly what we wanted. So the question is, how can we actually make this mana value be connected to the class we have created before? So there are what I would call a lazy way, and we have what I would call an efficient way. So the lazy way is the fastest way to achieve that, but it is going to be the most expensive one. The lazy way is actually, no, we have 2C here. In that. Anyway, the lazy way is actually to every frame update the mana value to have it display the current value. Actually, I'm pondering right now, and this is what we're going to be doing at the moment. Because the efficient way takes a little bit more time, and the timer of my episode is actually quite high, and I don't know if it's because I lost a lot of time on the side or if it is because there's a lot of content. So just in case, I will be considering there's not much time. So in my user interface here, I'm gonna rename this mana label, and I will create a script for it. So I'm going to override the process function. And every frame, as I said, I'm going to update the text of the label to mirror the actual value of mana. Here, the text is going to be equal to, I'm going to use $string, it's going to be mana, and now the value. This curly bracket, and we're going to go fetch mana.mana. Right, because this is the mana class that we access by its class name, and then we can access property because it's static, which means that we don't need to create an object for it. Alright, so we're gonna keep this label on the side. Now, let's see. Well 2D. So well 2D, we have this button and everything. We're actually gonna initiate this mana. Let's say that we want to initiate it. On ready, so we have the button press being connected. But here, let's actually create a new method, like a public void initialize mana. Or that could be initialize game, whatever. And here, the mana will be set to 500. So the reason why I'm not using the create method here, because I want to set it 500, right? So for some reasons, let's say that you play a game, you end with 200 mana, then you create a new game. If you create 500, you're gonna end up with 700, not 500. So here, 500. Eventually, a method could be created for that, but at the moment, since it is public, I'm gonna use the fact that we're doing a little bit of spaghettiness to actually set it. Now, the second thing I'm gonna do is actually go in my enemy 2D right here, because in my enemy 2D I should have a function. Well, actually, it's right here. It's Banish. The enemy does Q. So at this moment, I'm gonna say that I actually want mana.consume, and I want to consume, let's say, 15 mana every time I banish an enemy. So we have actually two mana transactions so far, which we should be able to visualize on our header. So first, when we start the game for the first time, actually I need to bind this initial mana. I forget that. Let's initialize it after button. Initialize mana. So here we set the mana to 500, and then when an enemy reaches the end, it should remove mana 15 by 15. Right, so we have 500 mana. Okay, now the enemies move forward. Let's see if one is actually managing. Okay, we have a few enemies reaching the end, and here mana is going to be decreasing. Up, up, up. Okay, great. So as you can see, this is the lazy way, in the sense that we didn't do much coding and anything. It works, but it's not the most efficient way. Alright, so that's all. If you liked it, as usual, you can drop comments, likes, and you might also want to actually check the playlist if there are some episodes which are pre-released, because I've seen that basically they just only show if you look for them. So sometimes I have a few episodes ready ahead of the time, and if you actually want to watch them, you can access them with the membership. Anyway, you take care, and I will see you in the next episode. I'm out.